Sean.
Hi, Sean.
Okay, so polar coordinates. What you're going to do now with polar. Polar is like sweeping out. What they are thetas going on. Okay? So r theta. So what that represents is, let's think about if it's like this, right? Here's the y, here's the x. And I start here, right in the center is the origin. Polar, it's called the pole. So let's say I wanted to graph the point. Give me a theta. Pi. And let's say, give me a number not too big. 3. So let's say that I wanted to go and graph the point. What do we say? Pi 3. Okay. So what I'm going to do is I'm going to rotate myself until I get to pi. And then I'm going to say I'm going to go out a radius of 3. 1, 2, 3, boom. Right? So I've rotated pi and went out 1, 2, 3. So what rectangular point would correspond to this? What is that rectangular point? Negative 3, 0. Does that make sense? Now let's say that I said negative 3 here. Okay, so again I'm going to rotate myself until I get to pi, and now instead of going a radius of a positive 3, what do you think I'm going to do? I'm going to step back 1, 2, 3 while I'm facing pi. So then what point would I be at? 3, 0. Okay, so polar is like sweeping out around the pole now. Okay, and it's telling you the distance that you're going to go out when you're on that angle. Okay? Okay. So think about, again, let's say that I said 3 pi. So before we had pi, let's say I had 3 pi 3. Okay, so I said, whoop, there's pi. Whoop, there's 3 pi. 1, 2, 3. Where am I? Same spot. So are points unique? Polar points are not unique. You can find infinite amount of points in polar form for the same rectangular point. Okay? And that's what this is saying. If you add 2 pi times any integer, you're going to get back to that same exact point. Okay? Now, let's say that I went out pi over 4 with a radius of 0. Let's say I went pi over 2, radius of 0. Pi, radius of 0. Where am I at? Okay, so I'm at the pole. So when you have a radius of 0, you're not even at the pole. You haven't traveled, right? You have nothing. So that's just kind of, you're going to say, I don't need to worry about it. You'll see that in a little bit, okay? So that's where you're going to be at, like, you're not going anywhere. So we're going to think about then how we can translate from polar to rectangular. So if I have some theta and I swept out some distance r, and I said, well, that's going to correspond to some x amount, so xy, right? Some y amount. Agree? So this, I can form my right triangle, and how can I relate x and y's with r's? Well, x squared plus y squared would be r squared by the Pythagorean theorem. You will use that a lot. Then we said, well, what happens if I took the cosine of this theta? Cosine of theta is going to be x over r. So cosine of theta will be x over r. And then solve for your x. And what is it equivalent to? R cosine theta. So if you have the points, what do we say, like 3 pi, could you find that x value? So let's see, what's cosine of pi? Negative 1 times 3 is negative 1. Is that what we found just a little bit ago? Right, when we went there, negative 3? Yeah. Okay, so then what if I said, well, what's the sine of that angle? Y over r, solve an equation to relate x's and y's with polar. So these are the main ones. You can remember that, but you can always, like, that's easy to adapt to. All of the other trig things you can adapt to if you know those. Okay? Okay, so let's find the polar equation for this circle and support graphically. So what does that circle look like? Where's the center of the circle? Okay, 0, 3. What's the radius of the circle? 3. Okay, so we got that circle. So now let's convert this to polar. Well, if I'm seeing an x squared, what do I need to go with it? A y squared, because x squared plus y squared is going to give you squared. So what do you think we should do here? FOIL. Go ahead and FOIL. So the 9's cancel, right? And then what do I know? X squared plus y squared becomes r squared. And what do I know y becomes? The y's and sines always go together, and x's and cosines. Like, think about your unit circles too. You always have what? Cosine, sine, right? X, y. So, well, usually, like, sines and y's are always together. Okay? Okay, so now I've got something like this. I need to solve for r in terms of theta. That's our goal. Okay. So let's see what I could do here. Any ideas? Factor out an r, yeah. So let's factor out that r. What were you thinking? Okay, so when I have two or more things being multiplied that equal 0, what can I do with them? 7 each equal to 0. Well, r equals 0 is just the what? Huh? It's the... Yeah, so that's the pole. We're not worried about that. That's not going to give me any graph. So that's why we can just say, okay? So the graph I want to solve for is over here. So what's r going to equal? 6 sine theta. All right, so let's see how that corresponds. Now we're going to make a what chart? R theta. How can you remember, before we move on, think in your group, how can you remember it goes r theta instead of theta r? R theta. Think in your group how you can remember that.
R14. That's how it should be.
Okay, because usually you put x, y because your inputs are going to be right here, right? But in this case, we need to know our theta values, so like 0, etc. So here is finding what the r's are going to be, right? Kind of when you do it. Okay, so like I think rho theta, not theta r. Whereas usually the inputs are what go in the first column. That's not the case. Yeah. Okay, you could set it up this way, but it'd be really confusing. Okay? Alright, so let's plug in a theta of 0. Sine of 0 is? Alright, so I have this first point. That's when theta was 0, right? So let's go maybe what? Pi over pi, okay. I'm going to do 4. Let's go ahead and put our pi over 2 though. Pi over 2 would be what? Okay, so I'm going to face pi over 2 and go out 6. Right? Okay, so do you see how you just kind of like, you skip some things? So let's go ahead and look at pi over 4. What would pi over 4 give me? 3 radical 2. Gosh, radical 2s are actually really, really good in this case when you have pi over 4 like intervals, because think about this length right here. If this is 1 and this is 1, what's that length right there? Radical 2. You have 1 squared plus 1 squared equals c squared. C squared equals 2. So c would be radical 2. Oops. Right? So this length would be 1 radical 2. All the way out would be how long? 2 radical 2. 2. 3 radical 2. So 3 radical 2 will be at like that vertex right there where the 3's kind of come together. Does that make sense? So let's see, 3 pi over 4. What do you got? 3 pi over 2. So I'm facing 3 pi over 4. So I'm facing right here, and I'm going to go out 3 pi over 2. And then when I get to pi, what's happened? You're back to where you have started now. So how long, did it take for one cycle? You started right there, and you traveled like this, right? How long did it take? 0 to pi. So 2 pi. All right, so get your calculators out. Let's just see this. Go to your mode, take the polar. Then it's going to start repeating. It's just going to circle the same word over and over. So type in your mode to be polar, and now it's going to be an R equals. Your theta values are like second caret. Or not second, diamond caret. Yeah. So diamond caret are where your theta values are. Yeah.
What do you get again when you pull? You get to use the radius and crazy predicate, so you get your x value.
So right here, when I plugged in pi over 4, what's sine of pi over 4? Times 6. 3 radical 2. So when I'm facing, pi over 4 is like y equals x, right? When I'm facing pi over 4, I'm going to go out 1 radical 2, 2 radical 2, 3 radical 2.
Okay, I don't know what you're talking about, like 3 pi. You get 3 pi over 4 or something. Like you said,
To put that one in.
yeah.
We're picking different theta values so we can see the radius that corresponds with them.
I have a question.
Uh-huh.
So like, now like, 3 pi over 2. Would it be like negative though? So I'm not like, why do you say
Okay,
pi?
so yeah, so let's say 3 pi over 2. What do we get out?
Negative 1.
And then times 6.
Negative 6.
So I'm facing 3 pi over 2, and now I go this way. And I'm right there. Does that make sense? Okay. So when you graphed it, does it look a little bit elliptical? It's because your tick marks aren't the same. So if you want your tick marks to always be the same to see a better graph, zoom square. Now do you have a pretty little circle? Zoom. Okay. Okay, so why what do you want to type it as this right here? So sometimes you may complete the whole like cycle in pi. Sometimes it will only be in pi over 2. Sometimes it will take you 2 pi. And sometimes your graph may just never start touching. It may loop forever. Okay? Yeah, let's see. You can get some of those. It's called like cycloids, I think. Okay. Alright, so let's convert this polar coordinate to rectangular coordinate. To a rectangular coordinate. Well, there's a couple ways you can do it. I'm going to show you the hard way. X is what? R
Cosine theta.
cosine theta. Good. So x in this case, what's my R? 2 times cosine of pi, which would give you what? Y is R sine theta. So in this case, y is 2 sine pi, which will give you what? So this will convert, this is the polar coordinate. Your rectangular coordinate would be negative 2, 0. That's the longer way. The faster way is to say, face pi, go out, 1, 2. What's that point? Negative 2, 0. Yes, it does. Now, it's not always so easy unless it's on a pi over 4 or a pi over 2. Yeah, so if you got a pi over 6, it's probably easier to do it the first way. Okay? But in this case, when you have a pi over 2, any of those easier ones, I would just graphically. Alright, so let's sketch the graph of this guy and convert to polar form. See what you can do with your group.
There's an A in there.
That's okay. Okay, it's just some constant value.
Alright though. Alright, so which way it was graphic, whether it's polar form or the rectangular form, like which was easier.
If you do the rectangular form here, you need to complete the square to get it into a conic form. If you graph it with polar, you're going to need to start with an r theta chart.
Like our picture.
Okay. It's okay to have A's. Just make your tick marks instead of like going by ones or twos, make them go by A's. No. We'll handle like integration with A's and we'll carry A's over, you know, like,
Yeah.
but it won't be able to graph it for you. You have to do it without your calculator. Yeah.
Just like a small. So if you're going to make a r theta chart, you usually want to include your pi's over 4, 3 pi's over 4. Okay? 5 pi over 4 needed. Gotcha.
So when you face 3 pi over 4, you're going negative, so it's that way. That's so it looked like all of you wanted to do the r theta chart here. Let's get some of those. At 0, where were you? 2a? Okay. At pi over 4, where were you? Radical 2 times a? So you get that little vertex, right? I think 45, 45, 90. Okay. And then at pi over 2, where were you? Facing that way from here. And then this is the tricky one. What about 3 pi over 4? Okay, negative radical 2a. So if I'm facing that way, I'm going to go backwards. I'm going to go backwards since it's negative. So it's right there. And then I'm back to where I started. Okay? Something like that. Questions? Do the next one.
So like you're clicking the points like exactly on 1A, but it's not necessarily true. Like it's as high as like A.
Yes, it is. And that's why I'm using A's, so that you can actually, whatever number's there, hopefully you start seeing things going on. Okay? And that's like that page 690 I told you to start looking over.
Yeah.
Yeah. Yeah. So is it easier to graph this rectangular or polar, you think, for this next one? Yeah, definitely rectangular. X equals 10. Boom. You know how to graph that rectangular, like, really easy. So then convert to polar still. I still want to know, can you convert it to polar? If you've got your conversion to polar, I'll check it. And that's all for R. R in terms of theta. X. So you could get 10 over cosine. Make sure it's R equals in terms of theta, which is the same as what? 10 secant. Okay? Either way, I'm fine. Alright, so that is what I would have hoped you would have already had coming into this class. That's your intro to polar. So we're going to take a little break, like 2 minutes or so, and then we're going to get to some calculus.
You should make up analysis.
Okay, so
We do number lines again.
if you want to stand, get another little half brownie, start with the half piece.
Go ahead. I could do the number lines. Yeah, that's what.
Yeah, really so.
The whole day just making a huge sign.
The number line. Like, well, how to plot points on the number line.
I'll take whatever part you want.
You'd be kidding me.
So this probably would have been a couple days of trig if you get it for a half day calc.
They need to do some math analysis.
They have it now in accelerated trig. So. I know. But like I can get you there.
Dude, you need to look at the math analysis curriculum of number line again.
Like, I'm not like, you think I'm like pulling your leg or something. I'm completely serious.
I have to learn how to like put it on the line, whether or not shade in the point, and then which way it goes. I'm like, it's like algebra 1A concept. Yeah. Conics. Oh god. Get on that free time already.
You learn to tell where it's going. That's important concept. But it's like that. But that's well, but there are some people it's not. So that's good. It's still like.
I'm just like,
I can't remember. You guys had that.
yeah, you did. I love that. That's really depressing. Like, certain mechanics always got so mad at me when I, like, didn't take notes. Because I wouldn't take notes. Because I'm like, I know all of this. Like, I just covered this in college algebra. And he got really upset with me for not taking notes. I'm like, I don't have to take notes. I'm not, like, sleeping during your lectures. He got really upset with me. I was like, alright.
It's like, I know some, right? Didn't he get, oh, wow, this is I look at it. I'm so mad. Okay.
Okay, alright, Josh is great.
Let's say I'm like, I'm numbed by all this stuff.
Every other mouth has been
Are you usually in cases?
Yes.
Oh, fuck. She's eating my guts. I was thinking bananas like mad.
Henry, you okay?
Yeah, hated like master like first time was like
Alright, start to regroup. We're gonna finish. So, just a little note. I don't mind talking about like your analysis, but let's not.
I just had to express my feelings. I'm sorry.
That's okay.
So to speak from one person to another.
Okay.
You didn't like that.
Okay, that's alright.
I'm still recording. Like,
It is.
it's alright. This is Rex knows right.
Okay. So, now what we're gonna do is find slope, and then we'll get some other fun things too. But first we're gonna do the slope in polar form. So remember back in parametric how we did parametric the dy dt over dx dt? Well, this is very, very similar now for polar. We're going to do dy d theta over dx d theta. So if I'm given r is some theta, function of theta, right? R is in terms of theta, it's a function of theta. I cannot just go find r prime for the slope, okay? If you did it, you're like, oh, this is easy, r prime. No, it's not that easy, okay? It is more complicated than that. R prime we're going to use in a little bit, but it's not to find the slope, okay? So, to find the slope, you have to remember what x and y are equivalent to. X is what, Hugh? R cosine theta, and y is r sine theta. That r is a function of theta, right? So we're going to have r as a function of theta. So we're going to have to first get what those are for x and y to do dy d theta dx d theta. Now, once I get here, I can find that derivative. Well, I could do the first times the derivative of the second plus the second times the derivative of the first. There's your dx d theta. Over here, I could do my first times the derivative of the second plus the second times the derivative of the first. So all of those numerators and denominators are product rules, okay, for that general formula. Sometimes it may be a product rule when you get it to simplify, sometimes it may be a chain rule, whatever. You have to get it here and take those derivatives, okay? Take those derivatives for the formula. Is that okay? Questions? Can you just take r prime? No. No. Okay, and just like we learned in parametric, if I set the dy d theta piece equal to 0, I can get out horizontal tangents. If I set dx d theta, I can get out vertical tangents. If they're both 0 at the same time, what are you going to have? Not a no solution. No.
Oh, that's what I think.
I heard it. What? Indeterminate form. Okay? So that's an indeterminate form, and you cannot draw a conclusion. Alright? Okay, you ready for this? Ready for this? Which one do you want to do it first? Vertical or horizontal? Horizontal. Horizontal, what do I first start with? X, Y, X or Y? What does Y equal here? R times what? R times sine theta. That's your general formula. R is that. So now I plug in what they gave me for my R. And there's Y equals. Now find dy d theta. And you can see if you got that correct derivative for dy dt. Is that your overall slope? No, that's just the what slope? The top, the numerator. Okay? But this will help me find the horizontal tangents. What do I have to set it equal to? 0. And they made my life a little bit easier. They told me I'm only going to look for thetas including 0 and not including pi in between those two. So, inclusive of 0, not inclusive of pi. So what am I going to get out for some thetas? What's that? 0, pi over 2, pi, nope. What, John? That's it. Because then you start with things bigger. Questions so far? Okay, we're going to pause because I can't guarantee these are going to be horizontal tangents yet. Right? Because what if I got theta to be 0 over on a vertical tangent part? Would it be either one? No, you have to throw it out completely. So now let's pause. Let's go do the same thing with vertical, and then we'll continue to find the points after that. Because it's squared. It's all squared. So that's what I got for my derivative dx d theta. Negative a sine squared theta plus a plus sine squared theta. Do we not get that? Are we okay with that? Alright, so now I want to set that equal to 0. So basically I know that a sine squared theta could equal a cosine squared theta. So you don't have to worry about the a's. So basically you're looking where sine and cosine equal each other plus or minus, right? So where would those values be, Josh? got the what going on? The squares, right? So even though you get plus or minus radical 2, it's still going to just be full squared, so the negative will fall. That. Look now, I heard it. Is that okay? Do you like that way of thinking, or are you want a different way? Is that okay?
Yep.
Alright. So, we need to check. Are any of these the same?
They're not.
Okay. No! So we can include them all. If we did have the same, we'd have to throw them out. They would not be included. Alright, so now that we've got that, it asked me to find the what? Points. Okay. Asked me to find the points. Did it say rectangular or did it say polar? It did. So let's go ahead. Let's find polar. Oh. Just so, in case I ask you either way, you will know how. Okay? So let's find the points now. Alright, let's go find the rectangular points first. So where am I going to plug in my theta to be 0 to get an x, remember an x comma y? Where can I find an x when theta is 0? Oh, look, right here. There's an x, there's a y, right? So go plug in your 0 and what you get out? 0, 0. Do the same thing with all the rectangulars in green. Evan, what did you get for pi over 2? Radical 2 over 2 times radical 2 over 2 times 5. So what would you get here? A over 2. What about this one? A over 2. What about this one?
Yes.
And? Okay. So those are your rectangular points. Now what if I ask you for the polar points? Polar points are going to be in what? Not x, y, but r theta. So let's go find what those would be at those theta values.
can't watch you stay with that.
Okay. One more problem today. Button all of those. Anybody one more time on this one? If I'd asked you to find the slope overall, what would you do? That divided by that, right? Okay.
Yeah, let's just find the second derivative. If we divide it by.
Well, you couldn't find the second derivative.
Yeah, I don't know if you ever find this.
Really?
I can't remember again.
Okay.
Yeah.
Just can't remember.
Let's just say.
Okay, so next what we're going to do is we're going to talk about tangent lines at the pole. So let's say I had this cardioid right here, and I pretend it's more symmetrical, okay? Like top and bottom. And I went through and saw this line right here. This is like an axis of symmetry. Agreed? Okay, so then let's say that I had this flower, and I put those lines like that. Do you agree that those are symmetric? They help you out. So this would be theta equals what? 0. Is it also theta equals pi? Yeah. So since it's repetitive, we're not going to write it over and over. Pi would be the same as 0 in this case for this line. So in this case, we have two of them. It would be theta equals 0 and theta equals pi over 2. Okay. These are actually going to end up being tangents at the pole. This, when it crosses through, is usually not going to be a tangent at the pole, but it's still going to help with symmetry. Okay? So you still want to graph all of these, even if they're not tangents at the pole. But let me explain what a tangent at the pole is. It's when your original function of theta, so r equals 0. When you get that to equal 0, those are all your possible tangents. Then you go and you find r prime. This is the only time when you're going to do r prime. Does that tell you slope? No. But if we find r prime and you plug those values into it, they cannot equal 0. If they equal 0, they're not tangents at the pole. If they don't equal 0, they are tangents at the pole. Okay? All right. So we're going to sketch this graph using the tangents at the pole, our theta chart, all of that. And actually, when I go to sketch, the first thing I do is set it equal to 0, and I find either the tangents at the pole or the axis of symmetry. So we're going to set our original equal to 0. So basically, it's where sine of 5 theta equals 0. So what values will I put in here that will give me 0? 5 theta would have to equal what? 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc., right? So that means theta would have to equal what? Yeah, divide by 5. So 0, pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5, 5 pi over 5, which is just pi, which is the same as the 0 line. So all of those are going to repeat. I don't need any more. So these right here are my possible tangents at the pole. If anything, I still always want to get them sketched even if they're not tangents at the pole. I know that's weird. Okay.
So now let's go find R prime. Sparky, what's R prime? Good. Alright, so now we're going to plug in these values. And I want to know, will they equal 0 when I plug them in? And you can do that in your head. You don't have to show me all that work. So if I plug in 0, what's cosine of 0? Not 1, or not 0. 5 pi would give me pi, cosine of pi. Not 0. Not 0, not 0, not 0, not 0. Does that make sense? So all of these are tangents at the pole. Huh? I know, right? I agree. I know, you won't get to see like me turning around or anything. I know. That's the second part. Okay. So I have those tangents at the pole. We're going to go sketch those first. It's hard, I feel like. Alright, zeros. Theta equals 0. Pi over 5. Well, there's pi over 4, so pi over 5 would be below it. Two pi over 5. Well, 2 pi over 5 is still below pi over 2, right? I'll give you a hint. All of those will be the same distance. Okay, like, I just start going. Forget a little bit. But they're all going to be like the same distance. Alright. Let me back to 5. So what kind of graph do you think it's going to be seeing all of this? A flower. Okay? So it's going to be a flower. If you start looking at page 690, you will see when you have sine and this going on, that you're going to have that many petals with sine. That's beneficial to help you out. Okay? So I'm not going to have 5 petals. So how many spots are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what do you think is going to happen? Yeah, petal is going to be symmetric every other one. So let's start getting an R theta to help us where some of those would be. Alright, well maybe 0 is what? 0, 0. Pi over 4, does that help me? What is pi over 4 going to give me? What was it? Negative? Yeah. I got
Negative radical? Are you sure? Are you putting it into sine? So pi over 4 is going to be sine of 5 pi over 4. Okay, so it's radical 2 over 2. Okay. So when I'm facing pi over 4, if that's like 1, I'm at half. Okay? Because you're half of the pi over 2. Eek, that's not helping me very much. What else do you want to try? Want to go to pi over 2? What's pi over 2 give me?
Must be like a calculator question if you ask something to wrap all the
No.
points.
Pi over 2 is negative 1? Alright, that's helpful. Okay, so I'm facing pi over 2, and I'm going to go back to 1. So that right there is right in the middle, right? So I know that that's the end of a pedal. Oh, blessings. Okay. So I've got that pedal. I can really kind of get the rest. Now, I don't know, like, exactly the way it's going to flow, but I can go ahead and say, if that's a pedal, where's the next pedal? Not here. Here. Okay? Not here. Oops. That's supposed to be. Not here. Here. Not here. Here. Those are all, like, lengths of 1. Not here. Here. That's really rough. Okay? Now, when you actually graph it, it's going to flow for you. Something, I don't know, I just messed up, but it will flow. Okay? It's easier, like, if you get more. It will be nice and close. So you could get, like, pi over 6, just squeeze in there. Okay, but when you go to do it for me, like, if you've got the pedals and everything and the links, yay. Okay? Yeah.
When I was little, I used to have these little, like, stencil things, but they were, like, heaters, and they locked in with a stencil, and you put your pencil in it, and you put it around, and it made pedals of
Yeah, bring it.
I don't know if I have it anymore, but I
Yeah.
use it all the time.
That's awesome. Yeah. That's awesome. All right. So the hard part here are that sometimes you're going to have a pedal in every single one of those little spaces, and sometimes it's every other one, and that's what you're going to have to know. Start looking at page 690. I've said that for over a week now, I think.
For over a week.
Close enough. We'll round up. All right.
Wait, what did you say? What did you say?
No, it was definitely 2 days ago, because I was there that
It was Monday.
No, I was there 3 days ago.
Well, I've been saying it for
Because I was there that day, and on Tuesday, I was looking Wednesday.
I showed it. I even like went around. So there's your little joke.
There's like 2 jokes? I'm confused.
Yeah. I liked it. Funny.
You know what?
They can see the moon. So they can see Earth's moon. Well, it's fine. Show a picture of your signal.